Good afternoon, everyone. Everyone hear me okay? Yep. Okay, great. Thanks so much for being here. So I named this presentation, You Are What Your Bacteria Eat, because you'll see that's a kind of common theme throughout the presentation. First, I thought I would just go through some definitions of words that you might be seeing around in the media. And I actually had to look some of these up too, because I'm like, what is the difference between microbiota and microbiome? So basically, the microbiota is referring to the microbial community. And the microbiome also refers to the microbiota, but it can also refer to the genes within the microbes as well. Metagenome is a collection of the genomes within the microbiome, and biodiversity is basically a measure of the complexity of that microbial community. So the role of your gut microbiota, it plays a very important role in our lives and how our bodies function. The composition of gut microbiota is unique to each individual. It's like fingerprints. So it's going to be different depending on who you are, where you live, your environment, and definitely your diet. The microbiota contains tens of trillions of bacteria, 10 times more than the cells in our body. There's also 3 million microbial genes in our microbiota, which is 150 times more genes than even the human genome. And in total, it can weigh up to about 3 kilograms, which is the same size as the human brain. So this is just a schematic about your microbiota that I thought you might find interesting. What I really found interesting is that your GI tract, where this microbial community lives, is basically the surface is as big as 2 tennis courts, which is pretty crazy to think about that in your body. And laid end to end, our body's bacteria would actually circle the Earth 2.5 times. So it's quite a lot going on there. So there's a lot of different reasons why the microbiota and the diversity of your microbiome is really important. It helps with proper digestive functioning. It helps to digest certain foods that the stomach and small intestine has not been able to digest. Also helps with the production of certain vitamins, specifically B and K. And it helps combat other microorganisms that are more like aggressors. So it helps boost basically the barrier function of your gut to help improve your immunity. And now it's actually even considered an organ, or more specifically an acquired organ, because as babies we're all born basically like clean slates with no microbiota, other than certain things that you get from your mother. But basically intestinal colonization starts right after birth and evolves as we grow. And there's different ways that it does evolve as well. The aging process is very important in terms of your microbiota. Basically, as you age, it's going to start changing a little bit. And it looks a lot different. Even if your diet has stayed the same over the years, your microbiome will shift a little bit as you age. And while the general composition of the intestinal microbiota is similar in most healthy people, the species, there's different species, that's very personalized and unique to the individual. And I thought a good example was for like the Japanese culture, they eat a lot of seaweed. So they have evolved to have the bacteria, the marine bacteria that can actually digest that seaweed. So someone who maybe doesn't consume seaweed on a regular basis won't actually have that component to digest it well. So that's one way that the microbiome really adapts to your diet. And although it can adapt to change, there can be something called dysbiosis, which is basically an imbalance between the good bacteria and bad bacteria. And this can be this is where chronic disease and chronic conditions really comes into play with your microbiome, because when you have this imbalance or dysbiosis, that could lead to health problems such as functional bowel disorders, inflammatory bowel disease, allergies, obesity, diabetes, cardiovascular disease. So there have been a lot of studies recently about prebiotics and probiotics and their beneficial contribution to the health of our gut microbiota. Okay. So prebiotics basically serve as food for the bacteria living in our guts. They help improve the functioning of microbiota while allowing the growth and activity of the good bacteria. They're present in fermented foods such as yogurt and things like that. They can also be added to foods, to functional products. You may have seen that around in the store recently. And they're also basically indigestible for us. So our bodies necessarily aren't using the nutrients, it's more the bacteria that's using the nutrients. So prebiotics are very important. Probiotics probiotics introduce good bacteria into the gut. But like I said earlier, it's really the prebiotics that are acting as like the fertilizer for the good bacteria that's already there. But probiotics can help with that dysbiosis. So it helps you get the balance and avoid this imbalance between good guys and bad guys, basically. So food sources of prebiotics are listed here. Just a few examples, but chicory root, I know not really a super common food, but raw banana, oatmeal, legumes, a lot of wheat bran and wheat products in general, asparagus, onions, garlic, pretty common foods that most of us probably eat on a daily basis. Food sources of probiotics are mainly found in live cultures. So yogurts, some soft cheeses, or even some raw cheeses, kefir, sour cream, and then fermented foods, such as kimchi, sauerkraut, miso soup, and kombucha, which is a fermented tea. So these are some places you can find probiotics. And there's also lots and lots of probiotics available in supplement form. We'll talk about that a little bit more. So now I kind of want to shift and talk a little bit about some of the common diets that people are following these days. And the first one I guess I would talk about is just with the traditional Western diet, which who knows what that really is, but right. But the more common diet. So let's say you're not really mindful of what you're eating and you just eating kind of what the environment provides. That is what I would kind of consider a Western diet. I think we'll talk about that a little bit more too. But I also wanted to address paleo. That's very popular these days. Some low carb diets. Kind of a new one on the scene is the ketogenic diet that people are following, Atkins and other low carb diets, and then talk about something called the microbiome diet. Although I'm almost hesitant to call it a diet, but it's really what does a nutritious eating plan look like to help have a healthy microbiome. So Western diet, this is kind of the characteristics that I view a Western diet as. Lots of refined flours and sugars, fast foods, unhealthy fats, generally low in fiber and low in produce. A lot of preservatives, artificial sweeteners, processed soy, GMOs, these long ingredient lists that have numbers and all kinds of things that you can't, actually define what they are. The Western diet, I feel, has veered away from the whole foods approach that is more beneficial for the microbiome. I also wanted to talk, before getting into these kind of fad diets, just about decoding fad food news. Every day we're bombarded with food news. detailing the latest and greatest diets, how to lose weight, how to boost your metabolism, what new superfood you have to put in your Vitamix every morning. So sometimes it's a little bit hard to decipher what is good information and what's misinformation. So keeping in mind, one of the most important things to do is just to realize that when you see a headline, whether it's on social media, in the newspaper, in a newsletter, it's really designed to grab your attention. So if you just read that, and I know everyone's busy and a lot of people just read that headline, like gluten-free is good, gluten-free is bad, coffee's great, coffee's bad, and you just kind of hang on to that headline. But it's really, really important to ask yourself some other questions about this news report, or this Facebook post, or wherever you're getting the information. So the three questions that I feel people should ask is, what is the scientific basis for the headline? And under what circumstances was the research performed? So often these articles, like you get the clickbait from the headline, but then the article itself often will link to research. So it's important to get the source behind that headline and behind the actual article itself to see if you feel like it's valid for you or not. Another thing to look at is funding. Who funded this research? This is important just in terms of conflict of interest. One example I can think of is like a big soda company funding research that says soda consumption does not contribute to obesity or weight gain or diabetes risk. So I'm not saying that all industry-funded research needs to be thrown out, but it should be taken with a grain of salt, just kind of keeping that in mind. And the third thing to think about is it's important to assess your own personal health factors and what diet makes the most sense for your personal health. So, for example, if you're someone with diabetes and you read a research study that says eating a case of blueberries every day will prevent cancer, well, maybe that is true, but is it really good for you to eat a case of blueberries since you have diabetes? So you kind of have to just weigh the pros and cons and the benefits to yourself individually, because there's no one diet that, no one size fits all type of approach when it comes to food. So just think about those things when you do read about this type of information. All right, so going into these more common diets these days is the paleo diet, also called Paleolithic, caveman diet, primal, hunter-gatherer. The premise of this diet is based on really two central ideas. One is that we as humans have adapted to eat particular types of foods. And the second idea is that to stay healthy, strong, and fit and avoid modern diseases or diseases of affluence, such as cardiovascular disease, obesity, diabetes, we do need to eat like our ancestors. So that's the basic premise of this type of eating style. But really, there's no, it's interpreted differently by different people, but even our ancestors had access to different foods. So it's really hard to pinpoint, like, this is what you should eat on a paleo diet. This is not based on what people have done in the past. People are eating differently across the globe. But the way that it's interpreted now, mainly through the media and stuff like that, is there's allowed foods and not allowed foods. Which is like my least favorite way to promote a diet, is saying you can have this and you cannot have this. But this is how it is with paleo specifically. It does allow a lot of animal products, but does recommend the grass-fed, organic, free-range meats, poultry, fish, eggs, honey. But all of those are allowed on this plan. Roots, tubers, so things like potatoes, sweet potatoes, leaves, flowers, stems, or just vegetables. So vegetables are allowed. Fruits, nuts, and seeds, eaten raw. So very minimally processed foods. What it does not allow is what is commonly thought that our ancestors didn't have access to, and it's grains, dairy products, and legumes. So in terms of your gut health and boosting the health of your microbiota, there are definitely some pros to following a paleo-style eating plan. Generally, you're going to have an increase in fruit and vegetable consumption, which will provide you with both the pre and the probiotic aspect. If you are eating meat and fish that's grass-fed, it is going to be higher in omega-3 fatty acids, which are anti-inflammatory. And generally, you'll have a better omega-6, omega-3 ratio, which is also good for decreasing inflammation. Some of the cons of this type of eating, is even just the premise that these foods, grains, grasses, that type of thing, weren't available over 100,000 years ago. So there's really no evidence that that's true. Also, elimination of grains and legumes cuts out a lot of natural sources of probiotics. And you could ultimately actually lower the diversity of your microbiota by eliminating these types of foods from your diet. And as we'll talk about a little bit more, the microbiome can adapt to the foods that you're eating. So as our diet has evolved and changed from 100,000 years ago, so has your gut. Your gut has responded to that. So just the premise that you can't eat grains because our bodies aren't adapted to it is not necessarily a true statement. I'll kind of start going through this a little quicker. So low-carb diet, there's the ketogenic diet. Has anyone heard of the ketogenic diet? Okay, good, so a lot of people. So in general, the ketogenic diet is a very, very, very low-carb diet. Only about 35 grams of carbs per day, which is about the size of a banana. So that's very, very restrictive. It's also low protein. So it's a little different than Atkins and paleo, where it's also low protein in addition to low carb. The goal is to attain ketosis in the body, which burns fat instead of carbs for energy. That's the main premise of it. Ketogenic diets were actually developed and are consistently used in a pediatric population with seizure disorders and epilepsy. So it has been well studied in that population to have a really positive effect, but somehow it just got rolled into like the newest popular weight loss diet. As you can see, I won't go through that whole list, but there's a lot of rules. Eat this freely, eat occasionally, and then avoid. That's a pretty long list of things to avoid. So in general, I feel like it's a little bit overwhelming for the average person to be following this type of diet. And it also does eliminate a lot of the prebiotics and probiotics that we need for a healthy gut. Atkins is very similar. It has lists of what to eat and lots of things to avoid. The one thing I'll point out is that I don't agree with is the avoiding of certain fruits and vegetables. And sweet potatoes and things like that. But they have recently changed the plan to be these phases to kind of kick off your weight loss and then slowly add back in certain starches, grains, that kind of thing. So it's not super imbalanced, but you just want to be careful in those first few weeks. That can definitely have an impact on your gut. Similar to paleo, you should be eating more fruits and vegetables on these plans, which is good. Limited and processed foods, also really good. And some of the foods that are on the allowed list, you can turn into a probiotic food by fermenting them. So you are able to access some of those healthy probiotics. But in general, there is less fermentable substrate, and that's the kind of the key to the health of your microbiome is that fermentable substrate. Because all those bacteria need something to eat as well. And like I mentioned before, these are kind of difficult diets, they're really time intensive. They can be also very expensive, but at the end of the day, there's actually a little less diversity for your microbiome. So what we're looking for with a healthy gut is that balance. We're trying to avoid dysbiosis, which can potentially lead to GI issues, chronic disease down the road, that type of thing. So a balanced microbiome would be where you're having clear thinking, balanced moods, glowing skin. An imbalance in your microbiome can often lead to even mental health type issues like anxiety, depression. You can have insomnia, skin issues, all of those types of things if you're experiencing dysbiosis. Where paleo feels like our bodies can't adapt to a modern diet, the approach of the microbiome, or what's been the recent literature has been showing, is that the microbiome's population changes very, very rapidly. So you could literally wake up with one set of genes today, and tomorrow morning wake up with a totally different set of genes. It's very flexible. There are certain things that affect the microbiome, the environment that you live in, sleep, exercise, stress, but most importantly, your diet. So it's not, unlike the paleo view, it's not our genes that lead us to eat a certain way, but it's actually what we're eating that programs our microbiome. So this is kind of this is from a study that talked more about people following these types of diet. And basically in the study there was a group, there was a dietary intervention to alter the gut microbiome, basically. And the way that they did this was they assigned a group of people some plant-based diet and others an animal product-based diet for 5 days to follow this plan. And as you can see, the differences from plant-based to animal-based, the difference in the macronutrient profile. So animal-based was really high fat, really high protein, not super, super low fiber, but lower in fiber. Whereas in the plant-based, it was rich in grains, legumes, fruits, vegetables, lower fat, lower protein, and high fiber. So the way they studied this was they did a bacterial analysis of fecal samples collected before, during, and after the experiment to see the effect. And what they found was the effect was actually quite immediate. And each group, so I'm not saying that plant-based is good and animal-based is bad or vice versa. What this study was showing was just that the people were their gut bacteria changed so rapidly to this new diet plan that it, like in the animal-based, there was more bile-resistant bacteria just in response to eating more meat. Whereas in the plant-based group, there was a lot less of that bile-resistant bacteria because there wasn't a need for it, because there wasn't a lot of animal products. So it was really quick, immediate response to these diet changes. Just to reiterate, there's no one-size-fits-all. I really wish that there was one plan for every person. It would make my job, well, probably really boring, but a lot easier just to say, here's the diet for every single person. But that's not really how it works. In terms of these kind of the grain-free approach that's been so popular lately, that's hard because it doesn't give you that food for the bacteria that you need. And there's lots and lots of evidence about whole grains and their protection against heart disease, obesity, and diabetes prevention. Meat in general, moderate amounts. Too much meat can be actually detrimental to the microbiome, but again, it's like you've been hearing, probably your whole life, everything in moderation. So same thing with meat and animal products in general. And the Western diet that we talked about, I feel like you guys probably eat pretty healthy, that's probably why you're here. But too much of that processed food, too much sugar, all that kind of stuff, it does feed the wrong kind of bacteria, which is something to keep in mind. So, you know, variety is the spice of life, they say, and that's definitely true when it comes to your diet too. You want to feed the diversification of your microbiome by eating a very diverse diet yourself. Largely plant-based with whole grains, meat, poultry, fish. The addition of probiotics, specifically through fermented foods, is probably something good to consider. And this is like my favorite quote in the world by Michael Pollan, and I think this sums it up for the general population. Eat food, not too much, mostly plants. I think that's a good thing. It's very simple, like eating food, meaning actual food, not processed foods, packaged food, things you have to unwrap. You know, not overeating and eating lots and lots of fruits and vegetables. Great, so that's all I have. Thank you.
A lot of the stuff that I was going to talk about was covered very well by the first speaker. So I'm going to try to dive a little bit more into the science behind these diets and what they do to your microbiome, and actually how these bacteria are changed and affected, and how that may impact your health. And there's a couple of kind of fun anecdotal stories that hopefully we'll have time to talk about along the way. So I'm not going to talk about this because you did, but one thing I do like to point out is that we're 90% microbes and 99% microbial genes. So this was touched upon in the first talk, but I think that this is a very important point that is just makes you realize how important these bacteria are to our everyday physiology and our functions, our biological functions. So when talking about the microbiome and talking about how diets may affect it, you have to have a grasp of how your baseline microbiome is sort of set. And so that's why we're going to talk about birth. And so the first speaker did mention that your microbiome is sort of impacted by your mom during birth. But the way that this happens is that vaginally born babies acquire the microbiome of the mom's vaginal tract. And so that vaginal tract is filled with a lot of probiotic bacteria, like endogenous probiotic bacteria. That's the lactobacilli and the bifidobacteria that you see in these probiotics that you hear about. So as the baby is leaving the birth canal, it gets exposed to these bacteria. That baby's now colonized with that probiotic lactobacilli. A C-section baby is colonized by your mom's skin bacteria. So very, very different. You don't have lactobacilli living on your skin. Lactobacilli like places with low pH. They like places that are, to use a word most people don't like, moist. And so, you know, so these two sets of children are going to have very different microbiomes. And one woman's skin microbiome is going to be very different than another woman's skin microbiome. So already at that point, you're getting a lot of diversity. Now, what they found is that when they studied these types of infants throughout childhood, those that were born via C-section were actually much more prone to illness, were much more prone to infection than the vaginally born children. Now, what also influences our gut microbiome when we're born is how we're fed, whether we're formula fed or whether we're breastfed. Breastfeeding is very good for infants because it gives a lot of immune factors, and it promotes immunity and health, as well as providing some microbiome and supporting a different set of microbiome than a formula-fed infant. And so you can imagine all these combinations of breastfed, C-section, vaginally born, breastfed. So people have studied those, and I don't know all of the studies off the top of my head, but they're starting to tease apart how these sort of beginning factors do influence our microbiome. Now, it doesn't end there. And so one theme that I think is very important, and it was brought up a lot in the first 30 minutes, was the idea of diversity and how important and good diversity is. A low diversity in your microbiome means that you have less types of bacteria that can give you the factors that you need. And so over time. So this is a sort of a time course of gestation, infancy, all the way to adulthood. I have no idea what this girl's doing. And so as you age, so your microbiome undergoes a couple big shifts. And so the first is when you're colonized, when your mom gives birth to you. The second is when you go on solid foods. Your last big shift is sometime in adulthood, or adolescence to adulthood, where you start to establish your eating habits. So I think that's something that's very important, is when you're a teenager or a child, like adolescence, how you eat then does really shape your microbiome. Once that microbiome is set, it's really hard to change it. It's something we like to say, it's stable and resilient. And this is a point that I'm going to come back to at the end of the talk, because it's something that is really important when we think about diets and sort of these quick changes and turnarounds where people are doing crash diet after crash diet. So it's not to say that, so yes, the microbiome is hard to change once it's set, but it doesn't necessarily mean that it can't be influenced. And there is a lot of things that we do to our bodies every day that could influence the microbiome. The first is the amount of stress we're under. And so I don't think, I mean, maybe I'm like this, I hope you guys are not, it's just going out of your head, but stress can really have a big impact in anxiety on your microbiome. Overuse of antibiotics, that's a big problem in the United States. I know I do this all the time. Oops. The minute I get a sniffle, I want an antibiotic because I don't have time to be sick. Living with pets, why do I keep doing that? I'm hitting the wrong button. Living with pets, so the pet, if you think about what pets do and how they live, they're exposed to a lot of their microbes. And actually 80% of us share, or 80% of your microbes are shared between your dog and yourself. And actually what's also really interesting is that they've done studies where two people who live in the same household, if they have a pet, they share more microbiome with each other because the dog or cat acts as a conduit. So you're exposing the dog to your microbes, and then your spouse or partner pats the dog and now is exposed to yours and the dog's microbiome. Hygiene, enough said. And then daily nutrition, so how you're eating every day. So these sort of things can impact your microbiome. Your microbiome changes very rapidly. The bugs inside us can live only 20 minutes. So what they're exposed to, the environment, pollutants, all these things can alter the gut microbiome. But some of these are transient, unless you tend to be chronically dirty, chronically eating cheeseburgers every day, or you have an antibiotic you're taking daily as a supplement, I don't know. But those sort of long exposures and chronic exposures will alter your gut microbiome. So if you do go out and have a hamburger and french fries tonight, it's not going to ruin your microbiome forever. You're going to change it, and it will come back to what it was prior to that if you go back to eating the same foods that you were eating before the cheeseburger. So this is just a slide just to get you familiar with some names. Bifidobacteria, Lactobacillus, and Saccharomyces boulardii. These are common probiotics. They're also endogenous, which means they live within our guts anyway. And then these are the bad guys that live within our intestines, and the minute they get an opportunity to bloom and to grow, they will take it, and they can cause some severe infections. And this shift in balance is called dysbiosis. So now we move on to sort of the topic at hand, which is diet and the microbiome. At first I thought this was a baby carriage, but really it's just a shopping cart with a satchel of food. So the sort of history of food in agriculture, I think, is always kind of interesting. So, we talk about this Paleolithic diet and how to eat paleo. These back in the real paleo people, back whenever, it was mostly wild plants and nuts and seeds. It was very rare that they got to eat meat. If they caught like any sort of wild animal, it was sometimes it could be weeks before they were exposed to this. To actually have animal protein, but it was living off a lot of the proteins from the nuts and seeds and honey and things like that we gathered around them. Then the Neolithic Revolution happened, which was when people stopped living as hunter-gatherers and started farming, domesticating animals, and also growing foods, grains, and dairy. And then, badly for us, is the Industrial Revolution when processed foods hit the markets. This was all refined grains, fatty domesticated meats, alcohol, vegetable oils, and fast food all came out of the market. And so along with these shifts in these dietary habits, our BMIs started to change and to expand in relation to that. So this is BMIs across the US in 1985, 95, 2005, and 2015. And I don't really have to say too much, it's just looking at that, but this is over 40%. This means a BMI of over 40%, which is a very large amount of weight and obesity. So this is really a global epidemic. And so what does that mean? Western diet, what does that do to the microbiome? So if you think about a microbiome as normally it should be rich and lush and have a lot of diversity, a lot of different species of bacteria that can contribute to our health. And so it's really like a tropical rainforest with all these plants and all this greenery. Whereas eating a Western diet turns into like an over-nutrient or nutrient overloaded pond, where you still have some growth, but it's really sludge. And your guts don't look like this, I don't think. But the metaphor is there. So really you go from having all of this biodiversity to really just a couple of different things and maybe something you don't really want, like this gross stuff on the top of the pond. So, and this was supposed to illustrate, and I want to talk about this one study which I think illustrates Western diet and how scientists kind of study diet. So imagine this is a twin study, and they found twins that were lean, and their corresponding twin was obese. So it was one twin was lean, one twin was obese. So you had one twin lean, one twin in this pond. And so what they did was they took their stool sample and they gave it to something what is called a germ-free mouse. And so germ-free mice are, the story of the bubble boy who lived in bubbles because he couldn't be exposed to the environment? Well, that's what we do to these mice. We make these bubbles that they're raised in, so they're never exposed to any bacteria their whole entire lives. So they're sterile, they're completely sterile, there's no bacteria anywhere in them. And what we do is in order to test what stool does to our physiology, we'll give them fecal transplants, where we take the stool from a lean individual and we feed it into them. That bacteria gets into the intestine and colonizes the mouse. And then we let it sort of go and see what happens. Or we do stool from an obese individual and we see what happens. And so this is what happened. So we were able to transfer, not my group, but this is a study done by Jeff Gordon's group out of WashU, which I should have cited in here, but I forgot. So they found that by giving stool from an obese individual caused these mice to gain weight even though they're eating the same food. So just having a certain type of gut bacteria was able to promote fat absorption and fat retention. And so, So when they went to look at the two different types of bacteria, or they went to profile the stool, and they say, what bacteria are present? Can we identify if these bacteria cause fat and these bacteria cause you to be thin? They found a different ratio of two different groups, and we'll get to that. But these are called, this mouse here had a high number of Bacteroidetes, and these mice had a high number of Firmicutes. And so this was the original study, this was the first study that really linked gut microbiome to weight gain. So segueing into the hunter-gatherer or the paleo diet, instead of talking about CrossFitters and WODs, whatever those are, I thought we would actually talk about paleo hunter-gatherers and tribes that actually eat that same lifestyle, eat that same sort of idea of what paleo is. So this is the Yanomami in Brazil, I believe. And they never came in contact with a Caucasian or white person until like 1941. So they've lived pretty much untouched for a long time. And so people, of course, microbiome researchers, they try to find these villagers like out of the movie, and then they go and swarm in and they start taking stool and doing whatever they do with it. And looking and comparing it to our stool, this Western diet stool. And the only thing I want you to take away from this is that this is the diversity of the stool here. And you can see that in the US, we have the lowest amount of diversity. This is just basically sequences sampled, which doesn't mean anything. But we're very low on the diversity scale, whereas the other, especially the Yanomami, have this high diversity. they actually were colonized by species that we've never even heard of. And that's because they were eating this hunter-gatherer sort of lifestyle. Now, this slide was supposed to be, I thought that was out of order. So this is supposed to be after the stool study. So I just wanted to go over Bacteroidetes. So these are what you find in the lean stool. This is a tribe of microbes that specialize in breaking down starches. They break down fibers into short molecules that can be rapidly used as energy. Whereas Firmicutes, which is what was the high amount of bacteria in an obese stool, they promote fat absorption. And so if you think about it, once you start eating a high-fat diet and then you have microbes that really like and live off that fat, they're gonna grow, and because you're feeding them specifically. And so what you end up doing is you shift the ratio of these two groups of bacteria. And so normally we should have a 60%, 40% ratio, but in obesity what we find is you have a 60 to 70% here and 30 to 40% there. So it's really a big shift that happens. I was mentioning earlier that the paleo diet, actually the exposure to meat is not great. So sometimes, like this is a porcupine or a pig, I think, it occurs very rarely. And so a little anecdotal story I wanted to talk about was a guy who decided to go live with the Hadzu tribe in Kenya. And so he wanted to see what his microbiome would do if he lived an actual paleo lifestyle. So he goes to Africa, he sends a poop sample immediately back to the US for sequencing so we can know what's in his stool. And then he lives with them and they make him go out and they expose him to he goes hunting for 3 days, it's just 3 days. So he goes hunting, he's eating stuff out of trees, he's sleeping with the cows, because they sleep with their cows in their houses. And so for 3 days he does this, and he sends his stool back, and then he flies back to the US. And within those 3 days, his microbiome shifted completely. Completely shifted. All of the bacteria that he had present were not there anymore. He had all these new types of bacteria, the diversity was huge. And then he was only in the US for 2 weeks before it went all the way back to normal, to what it was before he even went to Africa. So that's what I mean about resilience, is that he went and he lived with this tribe, exposed himself to all these things that he's never seen before. His microbiome did change, but it wasn't long enough for anything to really stick. And so when he came back to the US and he started eating his normal diet, it went right back to normal. So just keep that in mind. And then this is supposed to be, I like this because I think this person looks very shocked at whatever he's doing. So if you actually, these are the two different, this was a study where they looked at people who are, these two different tribes. So this is basically a bunch of American volunteers versus the tribal volunteers, and you can see two very different, this is a metabolic profile. So metabolically very distinct, producing very different byproducts, using very different energy sources. So just goes to tell you how that, those microbiomes that are so different do actually have a big impact on our physiology. I wanted to quickly talk about the Mediterranean diet because this is the only diet that's actually been scientifically proven to have any sort of health benefits. The health benefits include cardiovascular health as well as weight loss. And so I'm not going to go over this, but this is sort of the idea. The diet mostly consists of a large amount of grains and fish and a smaller amount of dairy and cheese, and then very little meats, sweets and meats, red meats. And so how does the Mediterranean diet, why does it have such a potent health benefit? And one reason is something called short-chain fatty acids. And so I don't know how many of you are familiar with short-chain fatty acids, but they're something that really plays an important role in gut health. And so these are actually produced by bacteria. And so short-chain fatty acids are coming through the diet. The bacteria will produce butyrate, propionate, or acetate. So what this does is butyrate is the most famous of the short-chain fatty acids, and it induces gut hormones that tell the brain to stop eating. So it actually produces some satiety signals to tell you to stop eating. And it also has an anti-inflammatory effect. So some of the other short-chain fatty acids can cause inflammation, but butyrate will inhibit that inflammation. Propionate also will decrease fat production, so that way you don't make as much fat. Whereas this guy, acetate, is on the other side, he will increase your fat storage. But the foods that are in the Mediterranean diet are very high in chemicals that will produce butyrate and also and promote those bacteria that produce and respond to butyrate. The other things that are good about the Mediterranean diet is the omega-3s and the oleic acid, which also will provide. So omega-3 is fish oil. So if you've been hearing a lot, there's been in the press a lot as well as fish oil, and taking that fish oil supplement. This fish oil is an anti-inflammatory property. Omega-3 can suppress inflammation, and oleic acid is also a heart-healthy compound that you can find in some Mediterranean diets. So if we compare the hunter-gatherer microbiome and the urban microbiome, which is the Mediterranean, so this was a study that looked at the Italians versus this Kenyan tribe and compared their microbiome. And so I'm not going to go over all the different types of bacteria here, but the inside circle is the Hadza and the outside circle is the Italians. And what you can see is that the more colors you have, the more diverse your microbiome is. And the Hadza definitely have much more sort of colors around the circle here. And you can see that there's different proportions of some of the same bacteria. Some bacteria are not present in one group of people versus the other. Anyone's going to do that? At least the cap was on it. So I think the take-home message here is that these sort of eating habits between these two groups of people really affect the type of bacteria that are there. And these Hadzu are very lean people, and even though they eat a Mediterranean diet, the BMIs of Italians are much higher than the BMIs of the Hadza. This is also a really funny little anecdotal thing where, so this guy was in New Orleans and he eats a very high fiber diet, he's very health conscious, and so he has this sort of ratio of Firmicutes, which is not the best to have, so it's like, we talk about Firmicutes as fat storage, but so he was eating, but he was in New Orleans, so there's a lot of fried food in New Orleans, I know that. So, but his diet, he said, was healthier in New Orleans, but looking at this, I would question that. But he went to Western Texas for 2 to 3 weeks, and he ended up eating a lot of meat and steak and not eating a lot of what he normally eats. And what he ended up doing was promoting a complete change in his microbiome. But what's more important is this yellow here that all of a sudden pops up. That's proteobacteria. These are natural, what's happening here is he has endogenous pathogens, so commensals that live within your intestine. We all have good bacteria and bad bacteria there. Proteobacteria tend to be bad bacteria that live in our guts, and you don't want them to start expanding. And upon this 2 to 3 week stint in Western Texas, he ended up getting a bloom of proteobacteria. And it went back to normal when he went back to New Orleans, but I think this did go down, but it never went away. And so we do say, again, coming back to resilience and stable, for the most part, it was resilient. His microbiome returned back to what it looked like, but there was a tiny bit now of proteobacteria that has stuck around that wasn't there before. And so if you keep exposing yourself to this, if he was on a business trip or he was going to Texas for the next 10 years, for 2 or 3 weeks every month, then what would end up happening is that slowly your microbiome would shift and it would be sort of a mix of these two. So I think, yes, it's stable and resilient, but we do have the power to change it. So what happens if you do a 3-day cleanse? I'm obsessed with this lemon cayenne pepper thing, because I just don't know how people do that. And so this is a study where they took people that went on a 3-day lemon cayenne pepper drinking cleanse. So this shadowed area is when they were on their cleanse. So this is their microbiome before, and these are just different species of the microbiome. And what ends up happening is you see that during that 3 days, they start to spike in certain bacteria and then they drop in other bacteria. The bacteria that they drop in are, so the first thing to point out is the bacteria that they expand are Enterobacteriaceae, which are those proteobacteria. So these are not the good guys. This is not something that you want blooming in your intestines. But to combat that, they have this other bacteria called Akkermansia that is sort of what happens if you get damage, and so it's there to try to protect you. And so it is, I think, elevated just because of that, to combat that proteobacteria bloom. But then you can see here, these, let's see, down here we lost some, I think, Reciprotricaceae, which go ahead and try to pronounce that, and others. But I just wanted this to show you that, this 3-day cleanse does actually have a negative impact, potentially a negative impact on your microbiome. But 2 weeks after, about 10 days after the cleanse, all of a sudden it plops back down to what it was baseline. So again, it's the 3-day period is not enough to really change it. But if you were somebody who's chronically doing this, who's every time they're going out on a date, or there's like an event coming up, and they're either doing these sort of quick turnaround diets where they're really changing their whole nutritional exposures, you're going to end up probably having a bloom of these Enterobacteriaceae sticking around for a little bit longer. So, I mean, it's quite striking that it did stick around for as long as it did after the cleanse ended, where most of the other ones started to come down. This is just, again, I think the take-home message is stable and resilience. And so if you do a small little perturbation, like you go to McDonald's tonight because you're too busy to cook dinner, yeah, you're going to change, but you pretty much change back tomorrow morning. You'll be back to what you consider normal. But chronic exposures and what they call perturbation, so a change in your diet or a change in your environment, will cause a subtle dysbiosis where now you might have 1 or 2 new species of bacteria that are there because of this change. And how that affects health, we're still trying to figure it out. Give a piece of data from our studies, which is just to show you that how dramatic the sort of effects that the microbiome can have on our own tissues if we rapidly change. So fecal transplants are something that's really gone quite it's been quite much in the headlines, because this is the idea that you can take somebody's healthy stool and give it to somebody who's sick, and that will cure them. This has been done for C. diff infections, which are very severe, but they haven't had the best of luck with like inflammatory bowel disease or other diseases like that, but they're still working on it. So it seems that the microbiome could be a real cure-all, and so maybe a fecal transplant can make you fit, right? So, and there's anecdotal evidence of like a woman who got her daughter's fecal transplant and gained 30 pounds in like 2 weeks because her daughter was overweight, and the doctor hadn't really thought about that, but chose the daughter as a fecal transplant donor. Fecal transplant donors are usually somebody that lives in the same household, that's exposed to the same things, so it's normally your husband or your spouse, which I can't imagine that conversation at night. So what we did was we took a bunch of animals, and they were on a Western diet, so high fructose, high sugars, and high cholesterol, so sort of what you'd be like if you were eating McDonald's every couple days. And we took stool from animals that were either eating a Western diet, a paleo diet, or a low-fat diet, and we fed it to these mice. So we basically recolonized them with these guys, and then we let them continue to eat poorly, and then we looked to see what it did to their physiology. Now, this is what a normal liver looks like, so it's pink, and there's not a lot of these white sort of specks. This is what fatty liver disease looks like, so this is what they call steatosis, which is macro and microsteatosis, which is these fat globules. So all these little white circles are fat lipid droplets in the liver cells. This is so many 80% of Americans have some sort of steatosis. If you took that animal and you gave it a paleo stool FMT, you get all of this blue, and that means fibrosis and actually dead tissue. So there was something that happened when these animals received that paleo stool. So the microbes that were sort of induced by a paleo diet in an environment that was being kind of inundated with the high fructose and the cholesterol was very, very bad for the liver and caused quite a bit of liver damage. And so even with the low-fat stool, we saw the same thing. And so we're pursuing this a little bit, and I just wanted to put this up here because I do think it's a powerful image of where, we think that could be these quick sort of answers to our diets, or like a quick fix could be from stool transplants or quick changing in diets, and we just have to be careful of the effects on our physiology. So I'm gonna end it in a second. I know that we're gonna go a little bit long, so I will take questions after this, but can I go a few? So I have 2 more slides. So what should you eat to maintain a healthy microbiome? So that's probably why many of you are here. So this is sort of what the healthy microbiome or the microbiome diet is, but our microbiome is a unique fingerprint. And so we are not at the stage in science to say you have this microbiome, so you should do this diet. And I think that would be great if we could do that. And at some point, maybe in the future, we will be able to, but right now we don't understand that interplay enough to understand which bacteria do what and what's important. So what can you do to just maintain a good diet? Well, you should promote diversity. So that means avoiding antibiotics, pesticides, artificial food additives, and increase your fiber intake. Foods to eat. I think going to that Mediterranean diet sort of idea of nuts and dark chocolate, you can have red wine, olive oil, garlic, artichokes, and lots of fermented food like kefir, sauerkraut, kimchi, all the things that are going to promote probiotics and prebiotic, feeding prebiotics to the microbes. So we talked about probiotics, which are bacteria that seed the gut with a healthy mix of bacteria. Just be careful. I don't know if our slides are still up from the probiotic talk, where we talked about how to look at the labels and read and to know what you're getting when you look at a probiotic. And then prebiotics, which is what feeds the bacteria that you already have, and fiber. So I think our ancestors used to eat 100 grams of fiber a day. We're lucky if we eat 10 grams of fiber a day. So I think increasing our fiber as much as possible, all types and sorts, is just a good thing, and those are natural prebiotics. And so now I'm going to end this. I wanted just to thank the whole you for inviting me to speak again. I think we have one more of these coming up, talking about maybe inflammation and food additives. And then this is our center. So if you have questions, I guess we could take it now, and then that's it. So thank you.